These problems are the three most missed questions from the functions GVC test in this class. Number 2 was the most missed, then number 4, and then number 5. You can add these examples to your notes. For the first one, number 2, we have to identify each relation or graph to see whether or not it's a function. Remember, for a function, each input has exactly one output. For the first relation or picture, we have 5 points, and we have to make sure that for each x value we plug in, there's only one y value. So for example, if we go to where x is 0, we check that there's only 1 point on that vertical line down at -1, which is the y value or output. We check each one where there's a point. If we go to -2 for x, there's only 1 point down at -3. If we go to +2 for x, there's only 1 point down at -5. If every point or every x value only has 1 point, then that is a function. This is called the vertical line test. We can use the same trick or tool on every other graph. On the second graph, we can see an upside down triangle. Well, if we draw a vertical line, there are 2 points on that line, 2 places where we have outputs for that same input. That means this is not a function. Every picture we check. If we draw a vertical line and it only touches 1 point, we check and make sure that that's true in every part we could possibly draw a vertical line, and if it only touches once at a time, it is a function. The first one on the bottom is a little bit strange. We can check where there's lines and it only touches once at a time, but there is a point where it looks like it's touching 2 places, but the bottom point is empty or hollow. That empty circle means that that point does not count. It's an inequality, which means it's less than that point, but does not include that point on the bottom. So the top is touching, but the bottom does not count as touching. This means that it's still a function, since the only place where it would touch twice, the bottom point does not count. The middle one on the bottom point, if we try the vertical line test, it touches on the top and bottom at the same time, so that's not a function. And on the last relation, we can see if we try the vertical line at -2 for x, there are 2 different outputs or 2 different points on that line, so that's not a function either. On number 4, we want to get the domain and the range. Remember that the domain is going to be all of the x values and the range is going to be all of the y values. So first we have to find out what are the coordinates for each point, and then we can find the x numbers and y numbers. The first coordinate on each point is the domain. So if we find -3, -4, 0, and 1, all of the x values, we list them in those brackets as the domain. This is called set notation when we put them inside those brackets and have commas in between each number. All of the y values is the range, so we would go through each point and find that second number, -4, 1, and -3, and another 1. But because 1 is already in there, we don't have to list it twice. We just list 1, 1, even though it's located in 2 different points as the output. On number 5, we want to decide whether or not each equation is linear. Linear means that it would make a straight line when we graphed it. Well, there are a couple of giveaways. If we ever have exponents in our equation, that means it's not going to be a straight line because exponents curve the line. You can graph these using the Desmos.com graphing calculator if you wish. These ones without exponents, when we graph them, are straight lines, and so you can tell that they are linear because they make a straight line.